You always hand dig right up close to a pipeline. Machines could dent or puncture the pipe. Even a small nick in the coating could allow corrosion that could cause problems later. So when the machine works, even not so close in, you still want to keep a sharp eye out. This is the first time this 5-year-old line has even been excavated. It is a model excavation, 3 city blocks long, stairs sculpted every 15 meters, the dirt piled way back. And the sides are sloped to eliminate the chance of any sort of cave-in. They are going to move this pipeline over, and they will do it while the pipeline is still in service, pressurized diluent coursing through it.
Hey guys.
There has been lots of preparation, although moving operating pipelines is actually routine.
We completed the API calculations, and based on a 5.7 millimeter wall thickness.
API calculations. The industry has detailed procedures for moving pipelines while they're still in service.
We will be able to safely relocate or move the pipeline 1.2 meters.
There is also a hefty sheaf of plans for the project for which the move is being undertaken.
Well, I've taken a look at the most recent inspection data for the section that we're going to be opening up.
And from ongoing pipe inspection, they know what shape the line is in.
I have no concerns, and the pipe looks good.
Okay, slings around the pipe will be used to lift and move it. Slings that are rated for several times the weight they are required to lift today. 4 machines will operate together. Once the slings are ready, everybody out of the excavation. Our supervising expert in the foreground has been around pipelines longer than he'd probably care to tell you, and he has done this a lot. Just get tension on this closest sling. The pipe is to be moved to the stakes, but not all at once, and real gentle. Everything moves as one unit. Off with the slings, up with the booms. They will move along the pipeline, moving sections until the entire 3-block length is moved. Every dance team needs a choreographer, and in this gentle ballet, the advance is slow and methodical. It takes a while to move in sections and in increments. But wait, this section doesn't want to move.
In order for us to get the pipe back here to move in this direction, we've got to lose some more up here. We've got to move the pipe further inwards.
You're not going to break it or anything?
We're not going to break it. No, we're not. Oh, no. Don't worry about that. No, the stresses are very low. Very, very low.
They will figure it out. By giving a little more at the other end, the job gets done. The whole pipe is now over against the stakes.
For the average person, it may have seemed to have taken a long time, but it was actually a fairly quick process. You can see after about an hour and 45 minutes, we had the line relocated, and everybody did a fabulous job, and I'm very happy.
There it is, over where it needs to be. In this one spot, you can see there are actually 2 parallel pipelines. The larger 24-inch line brings bitumen blend down from the oil sands to market in Edmonton. The smaller 16-inch line returns diluent back up to dilute a new batch of bitumen. They have moved the 16-inch away from the 24-inch so they can work on the 24-inch line. The next step is to fill in the excavation so we can get ready for our real story. The hot tap and Stopple bypass required by Access Pipeline for its new Smoky Lake pump station. A lot changes in a week. The pipeline has been covered, but then sections have been dug up again. But this time, it's the larger pipeline that's been exposed, and in just 4 places. Next door, they're building a new pump station to increase the volume of diluted bitumen flowing to Edmonton. All this work on the pipeline is to connect the line to the new pump station. Here are the fittings to connect the new pump station, and the size is kind of overwhelming. 24-inch high-pressure pipeline. Your car tires are maybe 30 pounds per square inch of pressure. The line is now at 300 pounds, and it's rated for over 1,400 pounds. You need sturdy fittings. You can see down there how they're fitting up the connections to the new pump station. But let's change angle for what's happening to the pipeline. Our view is from the north toward the south. We zoom in a wee bit, and we'll focus in on the pipeline. Our two pipelines are buried again, except for 4 spots that have been excavated to do the required work. The first thing will be the installation of T.D. Williamson's Stopple fittings, patented devices that will allow the big pipeline to keep moving diluted bitumen as connections are made to the pump house. A bypass line will be attached to the stopples and bitumen blend will be diverted through it so it can keep flowing. The section between the stopples will then be out of service. Its remaining diluted bitumen will be evacuated, connections will be hooked up to the new pump station, and blend will be routed back to the main line again. Then the bypass will be removed, the stopple fittings will be taken down, and the abandoned section of pipe will be removed. Back at the blend pipeline, they brought in a sandblaster to remove the pipeline coating and expose the steel where the stopple fittings will be installed. If you've ever had ultrasound, this may look familiar. It's one of the tests to ensure pipe integrity where the pipe's exposed. Another test now, magnetic. Black iron filings against the white paint will show any cracks when magnetized. Why, you might think, are they applying flame to a pipe carrying flammable hydrocarbons? Well, it's another test. They measure how long it takes for the pipe to cool down, because if the product in the pipe draws away too much heat too fast, that could cause weld cracking. A fitting for the installation of one of the 2 Stopple trains. Access has hired T.D. Williamson, a world leader in hot tapping and pipe isolation, to do this work. This one piece is about the weight of a small car. It will hold the critical devices, the Stopple cutter and then the Stopple train, and will become a permanent part of the blend pipeline. The top clamshell has a corresponding bottom, of course. T.D. Williamson's procedures call for a backing strip here, so the fitting is not actually welded to the pipe at this point. They also tension the chain clamp so the fit is tight, but not so tight as to squeeze the pipeline. A first pass is welded, the root weld this is called. Then it's tested. And then a whole bunch more. The objective is to make the 2 halves one whole, one fitting that surrounds the pipeline. Even with 2 welders, this will take a while. Then they'll wait. The circumference weld directly to the pipeline is especially critical. This one last test checks especially for hydrogen-induced cracking. Cracks sometimes take up to 24 hours to appear. As per industry practice, they have waited 48 hours to do this test. Off to one side, they're building the bypass pipeline. This will undergo testing just like a regular pipeline, although this one's only very temporary. Sand blasting is actually glass bead blasting. Glass beads take off the paint but are gentler on the metal, which prepares the surface for epoxy. You mix it up and you have about 10 minutes to apply it before it gets too hard. This guards against corrosion. They will do 2 coats at both Stopple fittings. Fillcrete, a softer concrete with no aggregate. It will support the pipe as it bears several tons of weight, yet it can easily be broken up and removed if access ever needs to get at the pipe in future. It's after hours, everybody's gone home, best time to x-ray the welds in that waiting bypass pipe. The band he's placing on the underside contains the X-ray film. This device under the bungee cord will hold the source, the emitter. The emitter looks like this. This one doesn't actually emit, that's why we can show it to you like this. The real one is in the triangular container there, until our crew gets to a safe distance and can use air pressure to dispatch the emitter along a hose to where it needs to be, in that holder we saw under the bungee cord. They calculate each exposure individually. This one will expose through the pipe for 6 minutes to get a good X-ray image. Time enough for one of the guys to step into the truck and process previously shot films. They know immediately if any weld's a problem. They'll need 56 X-rays to test the welds in this bypass line, plus this line will be pressure tested to verify the pipe they've used is okay. The advance work is just about done. It's showtime. The fitting is securely in place, protected in its bed of filcrete. The T.D. Williamson technicians check the retaining ring that will secure the completion plug, which we'll see later. First up, the sandwich valve. This one sits on top of the Stopple fitting and allows them to shut off the flow of blend. We'll show you this in a minute. This weighs as much as 2 big pickup trucks. You need a crew that knows this stuff and a steady crane operator like Cool Hand Bob to guide it into place. And as they say, it's in the hole, gently.
It's a nice surface, but come up a little.
Now let's get in here. This is our best opportunity to see the functioning of the sandwich valve, which will open to allow blend to flow through the bypass line. Next, the Stopple cutter to cut into the pipeline. This is the weight of 2 big pickup trucks. It has the cutter at the bottom, a drive shaft running up that column, and hydraulics at the top to turn the cutter. Pressurized nitrogen in a truck nearby has been connected to the cutter. They will now connect the hydraulic lines to bring the power required to turn the cutter and make the cut. Last, the gauge that shows them the progress of the Stopple cut. This rod, with a little wheel on top, goes down into the cutter tower. They measure and mark. This white tape will let them know how deep the cutter's going. We can't see what happens, but we can show you. The nitrogen blanket is established at pressures matching the pressure of bitumen in the pipeline. Now the sandwich valve can be pulled open, and the cutter can be lowered into place to start cutting. Outside, they can monitor the progress. By watching the measured tape, they have a depth gauge, and the little wheel confirms the cutter's rotating. One rotation takes between 2 and 4 seconds. The cutter is turning very slowly. This will take a few hours because the cutter shaves just a few thousandths of an inch of pipe with each rotation. It cuts out a curved disc of pipe, a coupon. Bitumen keeps flowing, held down by the nitrogen blanket. The coupon comes out when the cutter is raised, and we will need the coupon later. The last thing will be to close the sandwich valve. The vacuum truck is always kept ready in case any bitumen spilled. It can be sucked up. But as the Stopple cutter fitting is removed, there isn't much to worry about. The nitrogen blanket has kept things clean. Cutter itself is messy, immersed as it was in bitumen in the pipeline. They get it out after several minutes' work, and we'll see it later. Should note here that they have put 2 other valves into the main line, cut like a miniature of the big cut we just saw. The Petroline guys have put a temporary cover or blind on here while they go do the same cut at the other Stopple location. Remember all those bolts? Tightening all these is going to be a little more complicated than putting on your spare tire. There is a specific sequence described in several pages of access bolt tightening procedure. These fellows are specialists at this. Work cannot be rushed. There is a specific torque for each bolt. Pressure is not applied all at once. They will tighten each nut in sequence, one by one, as many as 6 times. And with all these bolts, we're talking days to do this. Meanwhile, the riser segments to connect the pipeline with the new pump house will take some fitting. And because the underground line undulates as it parallels the ground surface, getting a precise alignment of old and new will be exacting. Mornings. It's okay to miss your morning coffee, but not your morning safety meeting.
The project today is to actually get the bypass in operation and get the Stopple plug set.
Access has developed a multi-page procedure for how to do this job. The detail is exhaustive but also essential, especially at critical, busy moments.
It's going to be a pretty tricky little move, so we don't want any interruptions. We don't have to worry about people that shouldn't be there to start with.
When you're parking your vehicles, try and keep out of the way. And say it's going to be pretty busy out there.
Fire-resistant workwear is mandatory here, and so is hydrogen sulfide poisonous gas training. And everybody carries a gas monitor.
These monitors monitor 4 things: poisonous hydrogen sulfide gas, carbon monoxide levels, oxygen levels, and the threat of explosion.
A passing pickup truck will sometimes set these things off. Here, sitting in its steel transport cradle, is the actual patented Stopple train, they call it. They're assembling the big pieces. These are the actual stopples. One critical component is the black rubber seal that seals against oil under pipeline pressure seeping past the stopples. You place the seals only at the last moment. In the Stopple tower, the stopples must fit tightly. Back and forth, carefully to avoid damage to the seals, they work the stopples into the Stopple tower. Now they can lift it over to be set onto the Stopple fitting on the pipeline.
Okay, good. Oh, we're twisting a little bit.
Despite all the machine power, it is humans who do the final placement work.
Yeah. Okay, fire up. Okay, we're in. Good. Go down.
This will have to be bolted up as usual. First, they'll bring over the bypass line and attach it to the stopples. They do this at both ends. They connect a small 2-inch hose from the main pipeline up to the upper part of the Stopple train tower. This will allow blend from the pipeline to flood in and fill the bypass line. When the bypass is full and the pressure is equal, they will open the sandwich valve. They slowly drop the Stopple train to double block the line. They're doing this at both ends so that oil will then be diverted through the bypass. The main pipeline section between the 2 Stopple trains now is double blocked at each end, isolated. Well, it's just about time to position the bypass line. Again, this is a temporary line to keep blend flowing while the main line is being diverted to the new pump station.
You're going to set the pace for us. It's going to be a slow pace, and that's perfect.
It does seem slow, but they don't have far to go and it takes just minutes. The center part up there can just drag along the ground.
That's pretty good for now, okay?
The trickier part will be the connections. This is at the south Stopple. The first bolts are easier, but they have to rotate the heavy pipeline ever so slightly to allow all the bolt holes to line up properly. It's a little different story down at the north Stopple. Still have to line up the bolt holes, but this time it's a shorter pipe. They left this last segment of the line separate to allow easier movement of machines during the most intense construction. This end will have to be welded to the rest of the bypass line and the weld tested as soon as the connection is completely bolted. First, cut the big piece to length. The first pass just burns off the pipeline coating. Then they'll go around again to actually cut the metal. Now they'll be able to clamp it together and weld it up. Pumps have arrived for the new pump station. It's the 1st of September, and today oil